Before we get started on this worksheet, there's something you need to remember. If I have a triangle, how much information do I need to guarantee that this triangle is unique? What three things will work? Side angle side will work. We talked about that yesterday. Angle side side does not work necessarily. Sometimes it will, but there's always a chance it's not going to work, and we'll talk more about that in a minute. What are the other three that angle side works, and side side works, and angle side angle. The only other one we don't have listed is angle. Why doesn't angle work? That proves similarity. Angle guarantees shape, but an infinite number of triangles are that shape. So you have to know one of the sides. Now, this one sort of works. Sometimes angle side side works, but sometimes angle side side doesn't guarantee uniqueness. It guarantees one of two possibilities. And we'll talk about that more in a little bit. So angle side side will work, but it often works twice. So instead of having an infinite number of triangles, sometimes it has one, but a lot of the time it has two. And we'll talk about why that's the case in a little bit. So let's consider each of these and see if the law of sines is enough information for these to work. The law of sines says the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. And really, you only have to use two of these. You can either do this one and this one, or you can do the B and the C together. It doesn't matter. Two of those three get plugged into the equation. Let's go over to my triangle. Let's test side angle side. If I knew angle A and side A, nope, that wouldn't be side angle side. Sorry. So this would be side angle side. So if I were to plug that in the formula, I know what the sine of A is, and I don't know, this would be unknown. And then I would not know the sine of B, that would be unknown, and I would know little b. Is that enough to figure out what the triangle is? Oh, I do know little b. Thank you. Sorry. So there are three unknowns there, and only two of them show up in the triangle. So that doesn't work. Well, if I tried to bring in the sine of C over C, this is unknown. So even if I get rid of that, wow, that was cool. How did I do that? So even if I did that, I still have two unknowns. Side angle side does guarantee uniqueness, but the law of sines formula will not tell you what the missing information is. Now there's another formula using cosine that we'll learn later, and that one will work for side angle side. So if we go back to this page, this one will work, but not the law of sines. Low sines. So today, if you're given side angle side, you can guarantee that the triangle is unique, but you cannot use the law of sines to figure out what the missing information is. All right, let's look at angle side. So if I knew angle side, would that be enough information? Well, the sine of A would be known, and little a would be known, and we would set that equal to the sine of B, which is known, over little b, which is unknown. And you notice we're only missing one of the four attributes, so angle side does work. So that is yes for law of sines. What about side? So if I knew all of these, can I use the law of sines? No. Because no matter how you set it up, Sine of A you don't know over little a you do know. So you would know this, and you would know this, and you would know this, and none of the angles are known. So you have to know at least one angle or this isn't going to work. Okay? What about angle, side, angle? Angle, side, angle. Is that going to work? This one's kind of tricky. Well, let me mark this as a 2. It doesn't look like it's going to work because we know an A, we know a B, and we know a C. But if I know A and C, don't I know what B is? Yes. So because I know both angles, that guarantees that I can figure out what the third angle is. And now I can match up the B's, and I can match up the C's or the A's, depending on which one I want to solve for. So angle, side, angle does work as long as you remember that if you know 2 angles, it's really easy to find the third. Okay, what about our favorite theorem? Angle, side, side. So angle, side, side. Is that enough? Yes. We know 2 A's, and we know 1 B, so we could use it to find the other B. The trouble is, a lot of the time, there are 2 B's that work. And we'll get into why that's the case later. So angle, side, side does work with the law of sines, but a lot of the time you end up with 2 answers because there are actually 2 triangles that satisfy that. All right. So let's solve number 1. Number 1 says, find AC given this information. So first off, before you do anything, what arrangement do I have here? Angle, side, angle. Is that one of them that works? Yes. So I'm going to label this as little a and this as little b, and we want to find b. So I'm going to set up the sine of 22 degrees over little b is equal to what? Do I want to do the sine of 118 over little a? That would give me 2 unknowns. So I need to figure out what angle C is. So I just take 180, subtract 118, and subtract 22, 40 degrees. So this is 40 degrees. So I put the sine of 40 over 24. Does everybody understand why I didn't choose angle A? If I chose angle A, then I'd have 2 unknown sides, and you need 3 of the 4 in order for this to work. Okay, so how do I solve this? So I just cross multiply. B sine of 40 is equivalent to 24 sine of 22. Then what? Okay, well, I'm gonna do it all at the end. How do I move this? Divide by the sine of 40. So 24 sine of 22 divided by the sine of 40. So little a is now 13.98. or sorry, little b. Now, does that seem reasonable? Why does that seem reasonable? How do I know it's the shortest side? So this angle is the smallest angle, so that side would be the smallest. And that angle is about half as big as this angle, so you would expect 24 to be quite a bit bigger than angle B, so 14 makes a lot of sense. So it's always good to reason through that every time you do one of these. Let's do number 6. Number 6 wants us to find the measure of an angle. It wants angle C. First off, what arrangement do I have here? Well, I have side, 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 angle, which is more than enough, right? So I have side, angle, side. I have angle, side, side. I've got all I need. We'll get there. Eventually you're going to invert it, yes. So I have to write the sine of C over 21. And then what other ratio do I need to pick? I've got to do the sine of 88. It's the only angle I know. So the sine of 88 over 26. So I don't really need to cross multiply this time. I can just multiply by 21. Cross multiply will work, but if I multiply by 21, now I have 21 sine of 88 divided by 26. So the sine of C is equal to all of this stuff, which is 21 sine of 88 divided by 26. So I have the sine of C is 0.807. So how do I find C? Invert the sine. Now, why is this a good number? Why is 0.8 a good number for the sine of C to equal? Sine is O divided by H, opposite divided by hypotenuse. And the opposite side is always smaller than the hypotenuse. 80% is a good number. If we would have got like 1.3, that wouldn't work. So I invert the answer, and I get 53.8 degrees. Well, you mean invert the 88? So she's asking, so here you want to do the sine inverse of opposite over hypotenuse equals C. But if this is labeled as C, where's the hypotenuse? It doesn't have one. It doesn't. What it has is an opposite and two adjacents. So this method only works with right triangles because you have a hypotenuse and an adjacent. But when the triangles become oblique, then all of those trig ratios you've learned earlier don't really apply anymore. All right, so let's do one more of each. So number 2. This is angle, angle, side, which is one that works. How am I going to set this up? Sine of. So let's use these because they're already paired up. Sine of 44 over 7 equals, well, first off, I want to know what this is, which is nice because it already lines up. The sine of 53 over x. How do I solve this? Cross multiply. 7 sine of 53 is equal to x sine of 44. So I divide by the sine of 44. 7 sine of 44 of 53 divided by the sine of 44. So this is 8.04. Does that seem reasonable? Why? 44 is a little bit smaller than 53, so 7 should be a little bit smaller than 8. Okay? All right. Number 9. Oh, let's not do number 9. It's angle side side, and the funny thing happens. I'm going to teach you that tomorrow. Okay, number 7. We have side, 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 and an angle, which is great. We have everything we need. We want to find this angle, so I'm going to match those up. What other letter am I going to use? I have to use A. I can't use B because angle B is unknown. So the sine of C over 20 is equal to the sine of 82 over 29. How do I solve this? You could cross multiply if you want, it'll work, but I'm going to, instead of cross multiplying like that, I'm just going to multiply by 20 and isolate the sine C. So the sine of C is equivalent to 20 sine of 82 divided by 29 is 0.68. Why is that a good number? It's less than 1. The sine and the cosine always have to be less than 1. If you remember from your graphs, the sine stays between 1 and negative 1, and the negative versions only occur in quadrants 3 and 4, where the angles are, bigger than 180, so we don't have to worry about that. So the sine of C is 68. If we invert the sine of 0.68, we get 43 degrees. Does that number make sense? Well, if I look at my triangle, 82 is about twice as big as 43. So we would expect these to have quite a bit of discrepancy, and there's not a ton, but at least the smaller ones matched up with the smaller one and the bigger ones matched up with the bigger one. Those ratios are never going to be perfect. If A is twice as big as B, angle A is twice as big as angle B, then little a is not going to be twice as big as little b. They don't work out perfectly. Okay, so today, I'm going to do 3, 4, 5. We did 6, didn't we? 7 we did, 8, and 10. And then 11 through 18, unless any of those are angle side-side problems. So look at number 11. What do we know about 11? Is angle side-side. So we're not going to do 11. What about 12? 12 is also angle side-side, so we're not doing that one. Maybe they're all that way. So's 14. So's 15. Okay, so we're not doing any of those. 18. You can do 18. And tomorrow I'll teach you everything you need to know about the Casey theorem. Okay. Good luck.